Alrighty, welcome to the AITJ podcast. My name is Sasha
Hello.
Cadariu, and I will be your host today. A little bit about me. I'm currently pursuing a master's in bioethics at King's College in London, where I am researching the dynamics of health-related mis- and disinformation as it pertains to surveillance capitalism and the commodification of behavioral data surplus. On the other hand, my work at AITJ has primarily involved content creation, namely surrounding the development of exponential technologies, as well as various issues in AI ethics and regulation. I personally have a deep-seated passion for responsible innovation, especially with respect to AI and sustainability. And honestly, I would like nothing more than to use the skills that I have to make the world a better place. So for today's episode, we're going to be talking about AI for business. And on that note, allow me to introduce our guest, Jarrod Teo. Welcome, Jarrod. Jarrod is currently the
Hello.
Chief Data Scientist at Direct Sourcing Solutions, where his work is aimed at providing innovative machine learning-driven solutions tailored to individual business needs. Jarrod has extensive experience analyzing big data. He's proficient in multiple programming languages and is especially skilled in predictive analytics and statistical modeling techniques. However, Jarrod has not restricted himself to a lab life. He has several more years of experience as a data science mentor and speaker, and currently holds a position with us as an AITJ ambassador. Thank you so much for coming today, Jarrod. Is there anything else you'd like to add before we begin?
Well, I'm happy to actually be the talk of this interview. I hope to actually answer as much as questions that you have, and maybe to show some coding as well.
Oh, cool.
As an example of why I actually say that I put practicality as well in terms of using theory to actually answer questions.
Mhm.
So it's always about balancing the two, theory and practicality of usage, because it is a lifelong journey to be a data scientist. Somewhere around the road, I'm obsessed with tools initially, but somewhere around the road, there was actually this CMO, Chief Marketing Officer, that asked me this question: Jarrod, you write good codes, but do you think your codes can sell? Yeah, they are business people. We must
Yeah.
agree with that. Yeah. Now the gap between the industry is that we have one side to be the data people, we have one side to the business people, but there must be a bridge between these two in order for the data science project to work. Yeah, that's actually the point that I'm going to actually share a lot during this interview. Yeah.
So yeah, I guess on that note, how would you say what is the best way to build that bridge? I mean, what kind of people do you need, and what kind of skills would those people need to have in order to be able to build that bridge and allow businesses to communicate with data scientists and become more data driven?
Okay. This is a good question. How do we build the bridge? The bridge lies with the data scientists, right? So how do you actually go about explaining things to business people is really very important, right? So instead of saying that linear regression is actually a statistical model that actually uses y squared max plus c, that actually uses b coefficient with actually the p-value to decide which predictor is actually important, by also to look at dummy coding. Well, somewhere down the road, the business person will say, are you going to teach me lecture? So the whole presentation become a lecture instead of a proper direction giving of what that they are going to actually do. Instead of saying that, why not actually say something like linear regression is actually a method whereby you put various business factor to actually see which customers actually have more spending or less spending in the next month.
Mhm.
Then it brings that excitement of bringing the business people to the table and say, okay, so we are putting in business factors. So what are the business factors are you going to put in? And of course, then the data scientist should have actually prepared this with the data master, right?
Mhm.
Whoever that is in charge of the database, or he himself should actually know what is in the database itself. What is the columns that is inside? How many missing values are there? And then decide which are the business factor that they want to actually put inside that machine learning model. And sometimes problems are actually not solved by using machine learning model. They
Yeah.
could actually be solved using a statistical method. For example, I actually met someone who said that, Jarrod, I want to actually grow my vegetables well. it sounds weird. It grows my vegetable well. But then that's actually a statistical cost. So that statistical cost itself, when I actually ask some of the fellow young data scientists, they say, well, you should leave it to the farmers to actually decide. The farmer will actually have the best idea of how to grow the vegetable well.
Yeah.
But then when I tell them that this is a national chemist from a government agency, the data scientist was like, whoa, that is an excitement. It's not actually just a simple answer. You say, well, I change your perspective. Then how do I do that? I don't actually jump into machine learning model. I was asking that the chemist, so how many methods do you have? Then the chemist was saying, oh, I have 3 methods. They said, oh, then I was asking them, 3 methods independent of each other, like 3 different methods? Yeah, 3 different methods. Then I asked them, do you have aging of the plants that you put in the 3 methods? They said, yeah, there's actually aging of the plants in the 3 different methods. We use different pesticide or whatever in the 3 methods. We are very interested to know what are the 3 methods out of the 3, which one is the strongest to actually keep the plants alive. Then I was telling the chemist, so it's actually ANOVA. So we'll look at the HOV, homogeneity or variance. And then we'll look at the test of the overall average. Then post hoc, then either look at parametric, non-parametric, and also look at maybe say LSD or James Howell or some other post hoc test and stuff. Then he was saying, what are you talking about? I say, in short, we're going to actually see which of the method keeps your plants alive.
Yeah.
The longest aging time, which of the methods does keep your plants alive? They say, oh, then that I understand what you're talking about, right? So one is actually technical view, one is actually practical view or layman view. So a skilled data scientist somewhere down the road must learn to actually teach all the jargons and then explain things in a very human manner.
Okay.
Yeah.
So it's basically this ability to kind of operationalize explanations in a way that are context relevant.
Yes, context relevant, something which they can explain to the entire group of stakeholders themselves, and then bring you into the picture and say, oh, look, this is the expert who can actually solve my vegetable growing problem. I mean, we as vendor or we as data scientists, we might not be the first person to speak at the stakeholder table. It is represented by someone who is interested to engage us as a service, right? So even in organization as well, we don't speak directly to the stakeholders or the investors, right? It is always the CEO or the C-level person who represent you. But if you can't speak in a human language, there's no selling point of view. They won't be able to actually tell the investor, we need this amount of money, $1 billion of amount of money, to actually support a project that will actually happen by Jarrod. Yeah. So then it makes sense for the investor to invest. Then that's actually where the human language comes to reach the data scientist point of the business group and the stakeholders. And then this is supported by the data itself.
Mm-hmm.
Yeah.
Mm-hmm. So, okay, interesting. So kind of going off of that note then, is there, when you're implementing, I guess, an AI-driven solution or machine learning or even a statistical modeling driven solution, based on your communication with relevant stakeholders or investors in that respective business, how malleable do you need to be in your mindset with the kinds of solutions and plans that you provide? I mean, is there a certain level of flexibility that you need to have as a data scientist, or can you kind of be a bit more concrete in the way that you present your solutions and implement them?
Yeah. So can I share my screen?
Yeah, of course.
Yeah. Okay. All right. I'm just going to show something on maybe say examples how I actually show how the solution work to customers, right? So this is actually a customer movement from 6 months ago, 3 months ago, previous month, and then the current month. So, okay. So what happened is that I will tell the business people or the one that is going to present me to the investor, I said that 6 months ago, this group of the customers are Princess, which is actually a premium customer, 2,270 of them. And then we see that at the current month itself, at risk of going to competitor, high-paying customer who have 1,184 of them. Okay, so easily he can actually just download the data, show data, and download the data, and then pass it to the marketing team and say that please do some marketing campaign for these customers who were formerly our premium customer, and then do something about them, right? So then you can see that this actually acts as an immediate insight picture to the stakeholder and say, oh, okay, so Jarrod's solution is able to find for me my former premium high-paying customers, and then now they are leaving the company. There are 1,184 of them. Yeah. But what if I tell you that in this dashboard itself, we have at least 4 machine learning models inside? Interesting?
Yeah.
Yeah. So if I were to show you the back end of it, I think any stakeholders will just actually look at it and say, how do you actually implement this one? So this is the entire workflow itself. Yeah. So the entire workflow, I run it. It actually run within 2 minutes and 34 seconds.
Wow.
So the entire workflow actually comes in at a data extraction. There are multiple files inside. It goes into multiple models. The models not only score, the models also self-learn, which means it's self-built based on the current situation in the market. What is the product that is available? They will actually self-build, self-learn based on the new data that actually comes in the picture. Yeah. So this tells me that even if I know that this customer that is actually, let's say that I'm not interested in looking at this, that my client always looking at this, that is, they are looking at corners who were actually high payers, right? Because they want to actually attract these customers back. Yeah, corners, high spender. Of course, then his favorite tab is this one, and say, oh, so what do I sell to my corners high spender? And then I say, oh, we'll sell them face masks, maybe. Face masks only come up recently because of COVID and things like that. They are a luxury brand. So these are actually some of the products that they can actually sell to the customer. The first recommended product, second, third, and fourth. Sorry about this one. Let me just put it back. Okay. So first, second, third, and fourth product. And then fifth and sixth is just behind. All right. So why high? Is because these are the high chance that the customers have a probability of taking it up. So yes, data science needs probability and statistics. So you see, this actually gives an insight that is so pictorial that immediately the stakeholders know what to do. What are the products to sell to the customers, right? Based on the profile of the customers. And not only that, that is if my client wants to represent me to the stakeholders, they can easily explain to the stakeholders what I am trying to do with the data itself. Not actually say, oh, I'll actually just do deep learning, a neural network, and all those bombastic jargons, which most of the stakeholders have oversold on the market. They'll just say, well, I don't know what's this. But then if they show, if they are shown this, that is corners, high spenders, we have 2,921 people at the moment, and then we can target this group with what kind of product, where can we target them, and all those information, they can easily set this up on the next month campaign itself. Cool?
Yeah, no, that actually provides a perfect segue into the following question I had for you. I was just wondering if you could speak maybe a little bit more about the importance of statistics and probability in data science as a discipline, in the ability to kind of derive concrete solutions to problems, and also target your methods in the way that you were just talking about.
Yeah. So as actually has shown to you, that is, I was actually talking about probability insight. So so there's a high chance, low chance, and all those things. All these machine learning models that you see at the dashboard at the moment, they are run by statistics. You can't escape from that. Yeah. So literally, if you want to be a data scientist, you need statistics. Yeah, cannot escape. Now, then this is actually another question that stakeholders will ask you. Okay, they will say, so yes, your machine learning models can work. I love it. We can implement, but can you tell me what is the result that we will see? Yeah. How much can you promise me that you will earn? Yeah, simple as that. So this is actually something that I measure on a quarterly basis. So you can see, I tag them in December 2019. I see their next 3 months earning, and I actually match a premium customer with a random customer.
Mhm.
So you can see the premium customers are spending this much. The random customers are spending this much. This is the earning by the company, by the way. So I'm actually saying the premium customers out earn the random chosen customer. So this is 5K sample. This is 5K sample customer. So I'm just trying to say that even before the marketing team actually sets out a campaign, they have the confidence to know that the customers are bound to spend. If I say that they are actually at risk, they are sitting on the bench. If I say that they are bonus, they are actually spending less than randomly selected customers. So this tells the marketing people, even before they set a marketing campaign, they already can have the confidence that the machine learning model can tell them how much the customers are bound to spend. Okay?
Yeah.
I tell you something that is even more creepy on this itself. Now, if you actually notice, this is April, it's going up. This is April, it's going way up here. Why is this so? It's because during this time, the lockdown of the country actually got loosened a bit. So from April and then next 3 months spending of May, June, July, the customers actually get to walk about and spend. So that's why you see a huge gap here in terms of spending. Yeah. So my model actually goes into the lockdown follow. It actually follows the lockdown of the country as well. I didn't put this in. The model actually self-learn and actually know about this one. Now, can the model work that is pre-COVID to COVID? So this is actually December 2019, which is way around that the COVID just about to happen. But the data actually the model is built on data that is pre-COVID, which is December 2019 and past 2 years. Now, the problem is a lot of people on LinkedIn say, because people's financial change, so the model is not going to work. But I did prove that the model still works even into COVID, April 2020. You see that?
Yeah.
This kind of model is very hard to build because it really look into the various aspects of the modeling itself to actually come up with a solution like that. And one more thing, that is, you see that August is supposed to drop down, right? December. We see that August here, it increased here, right? Why is this so? That the December 2021, it suddenly have a rebound here into this amount. It's because December 2021, 2nd December is where the country stops the lockdown. And the people is free to walk about again.
Yeah.
So my CEO say literally is getting creepy. Because Jarrod, how can you actually build a model like that? I said I can. Yeah. Even the buyer profiler, right? This is high spender. You can see the high spender is actually spending way higher than the random. When I say that they don't spend, they don't spend. When I say that they spend, they spend. Yeah. And for this one, next product to purchase, it is actually exactly the same. When I say that they have high chance, they have high chance. When I say that they have low chance, they have low chance. And then another thing is on the second product, why is there actually such a huge amount here? Is because the country is going into winter, right? So the customers actually, we able to walk around, plus going into winter. That's why you actually see such a high difference between the high and low chance, because the people here are recommended jackets. Yeah, jackets, winter clothes, and all those things. That's where they are able to actually spend so much, and given the fact that they can actually walk about. So this tells us that the model not only share during model performance phase that the model can work, but it also shares that after model being deployed, it still works. Yeah. So the point about being a data scientist is difficult is because when you're building a model, yes, 75% or 85% accuracy, overall accuracy. Confusion matrix shows that observed versus predicted, versus predicted is 75% or 85%. That's nice. But then when you go into deployment, you must hold your promise of the accuracy there. That's difficult. Yeah. And that is very scary as well. When you're trying to launch your model pre-COVID into COVID, that is even scarier. But I have an experience last time, because I was actually launching my model during the Thai protest period, before Thai protest period, and then I built data based on before Thai protest period, and during Thai protest period where they take over the country and all those things, I'm still able to actually get money back for the company. Yeah.
Wow.
So my friends jokingly call and say, Jarrod, you're basically a catastrophic data scientist. A new class.
That's a new job title right there, right? Catastrophic data scientist.
You're able to actually take on very weird projects, which other data scientists don't dare to take up. Not only that, Jarrod, you start with no data, no hardware, no software, no server, nothing. Ground zero, literally pen and paper. And yet you can come up with a model like that. That's why my CEO say that you're creepy, because Jarrod, you're not in the country, but you know exactly what's going on in the country. And you can even tell my client that which shop to close, which shop to keep, which shop is the flagship. And I even tell the person, they say, why is it that your new purchaser will always be of a certain shop? Then recently they tell me why this shop attracts new purchaser is because it's a tourist location. But they asked me the question back as well. How do you know? You are not in my country. You don't even live here.
No, it's incredible though, because you managed to highlight the role that that intuition actually, human intuition plays in building these models and allowing them to make accurate predictions, especially throughout changing conditions of life. So kind of what that makes me think about is the importance of data quality as well, and how you use it in these predictive models, and to the extent that it carries over different conditions of life. Like you said, building this model that managed to make these accurate predictions throughout the duration of COVID, from pre-COVID to COVID. So I guess I'm wondering,
COVID to post-lockdown.
Sorry, yes, COVID to post-lockdown. But yeah, so I guess I'm wondering if you could speak a little bit more about the importance of the actual quality of the data you're using, as well as whether you have personally ever encountered any issues with algorithmic bias. So like having training an algorithm on a particular data set, and then finding out that that data set is in some way skewed to represent something that perhaps isn't as representative of reality as the data would hope to be. Have you ever encountered that kind of problem before, or is that something you can talk a little bit about?
Actually, I'm quite lucky in the sense that I don't seem to have that before, because we always work with raw data, but we are very careful with it. Well, what we have is what we have. That's the raw data, right? Yeah. That's the customer spending in your company. We can't escape from that. So what is actually important to actually avoid that kind of bias is how you actually clean the data itself. Okay. Very important. Yeah. So last time we happened to actually have this issue, that is, there's actually this customer that has $100,000 of salary, and he is 18 years old, and he owns a main card. This is a problem already. So the legal age to own a main card is 21 years old. But how can he earn 100K a month, right? So 100K a month, we go and deep dive and look into it, because if we don't have a reason for this guy, it's going to skew our model because of this outlier of 100K. But to remove this outlier officially with the client, we have to find a reason for it. Then we go and actually check, oh, this guy is the son of the Sultan of the country. So that's why he can own a main card at age 18, and he earns 100K, which is actually the pocket money. So then, because of this, we really have to be very careful, not just actually looking into columns. We have to look at across the column as well in terms of the data cleaning itself. Yeah.
Yeah. No, that's no, it's very interesting, honestly. I guess to kind of transition a little bit, for you specifically, what kind of coding languages do you prefer to work in, or do you think that there are any specific reasons behind, the choices you make to use a particular coding language? Are there, any strengths, for using something like Python versus RStudio versus Stata? Because I know, like, RStudio and Stata tend to be more oriented towards statistical analysis, while R, you can build sophisticated computer vision programs with it. So, like, I guess I'm wondering, for your preferences and for your purposes, especially within the context of AI-driven solutions for businesses, what do you prefer, and what would you recommend as well? I mean, what would you say is best?
I don't want to create an R versus Python war after this interview. So I have actually been through SAS versus SPSS war. Okay. It's a very funny war whereby, well, it's the same thing. That is, SAS says SAS is best, SPSS say SPSS is the best. I become an SPSS trainer and take on the SPSS side. And well, now is R versus Python, right? But then the thing is, if you say that what R can do, SPSS can't do, or what Python can do, R can't do, there is actually always a pros and cons, strength and weakness of different software itself. But then software are software; they are tools. There's a hole in the office. We can't actually say, oh, let's look at different patching method, right? Yeah. The business people are actually looking. So how are you going to mend the hole in the office, right? So if you actually is obsessed of the two so much, then the actual business problem is not solved. But so what, you actually know, I came across a CV whereby the person actually had 50 software knowledge on his CV, but 0 business problem solved before. I didn't hire the guy. I didn't even consider him into interview. I'm so sorry if the guy is listening in this podcast, but then the point is that we are out to look at people who can solve business problems. And then it's a sad fact now that industry price on this one, and then there are entry people who come in and say, oh, I want to be a data scientist, but then I don't have a portfolio for me. And then what do? I go and find Titanic data. But you can go Kaggle. There's no wrong in it. You can specialize in a tool. No wrong in it. If you look at my screenshot, if you can look at my screen now, I look at various tools. This is Anaconda. There's actually Python inside. This is Alteryx. This is actually Power BI. This is SPSS. So then I when I actually look at more than one tool, I actually can understand why certain tool works in a way that I like it to be, right? So I can actually give you an example of SPSS here. You can see that there's no indent needed, right? There's no indent needed, right? But for Python, you need indent to work. Am I right? Mm-hmm. Yeah. But what if you need to actually put it in the function def? Mm-hmm. Can it automatically indent if you have 20K lines of code inside? Can you imagine the nightmare of indenting? So you can see that this is my define and define. This is the same as the def for Python, right? You can see that I actually have opened the file, I have computed the flag, and then I save the file, and then that's it, right? I will show in a while what these two codes work basically in a fun manner on why I emphasize that for coding, before you actually start the first line, you must think of the end result, which is, can it make money? That's very important. Yeah. So for the different tools, I will just say that SPSS have a certain strength and weakness that I like, right? authorities have a certain strength and weakness that I like. I don't want to cover what's the strength and weakness because I don't want lawsuit.
Fair enough. Fair enough.
Python and R also have a certain strength and weakness. I have not used R for quite some time, but I used to use R. So I will dare say that if you are a Python user, there is no stopping you for going into looking at R.
Mhm.
If you are an R user, there's no stopping you of looking at Python, because on different situations, you might actually fall on either of the tools itself. Yeah. So for authorities, I like authorities is because if I actually have 200 draft models to look at, I can actually say, oh, visually I'll look at model number 1, number 33, and number maybe 100 to actually look at it and then further enhance it and see what happens, right? If I were to do it in SPSS or Python, I can't do it. I would be looking at codes, and it makes selecting models maybe say slightly challenging at 3 a.m. or 5 a.m. in the morning, right?
I can imagine going back and forth can be pretty exhausting. Yeah.
So then it's a personal preference, but then ultimately when you're looking at the code itself, be prepared to answer this question before you even type the first line. Okay. What are you doing?
What are you?
Right. That's actually one young data scientist who come to me that Jarrod, I actually do a machine learning model using neural network. Very cool. And then he says that he uses conditional probability as a predictor, right? Mm-hmm. And then put inside neural network to run. I say there's no wrong with it, but what is the direction of your model going? What is it trying to solve? He said, well, you're not a data scientist, so you don't know. So I present myself. I'm a data scientist of 10 plus years experience. Can I know again, ask you the question again, why use conditional probability as a predictor to answer a dependent variable? And what kind of direction are you going? He can't answer me. He just said, oh, it's because it's cool. I use neural network. Then I asked him, do you have issue explaining this to your manager? Then he was amazed. He said, wow, Jarrod, how do you know that I have issue explaining things to my manager? I said, well, it's normal. If I as a data scientist don't know your direction, and you as your data scientist, you don't know your direction, no one will know. Right?
No, I mean, no, it makes perfect sense. How do you I think in any facet of business, you have to be able to explain the product that you're selling, and how it's going to benefit the person that's buying it or the entity that's buying it. So I think, no, it's a very important skill that you touch on, and it also relates to the following question. I mean, in your opinion, for data science, is there any major innovative point or maybe inflection point in data science that you can pinpoint throughout your experience that has been the most beneficial to the business world? Is there any function that machine learning or AI has developed over the last decade that has been especially useful within the business world?
At the moment, from what I actually see, is using maybe say no human being shop, the kind of automated shops, that Amazon has actually done. That is, you walk in, you take a product, and then you leave. This is actually very convenient to people. And from what I actually observed for the data science itself, it all works about how convenient your product is to actually make it easy adoption for people. So if it's actually very easy to use, like not this one is not easy to use, but this one, right? That is, if I present this to a shop holder, a branch manager, and say that, do you understand that you're targeting goners and high spender, and these are the group of people you're targeting? They say, yeah, it's so easy. And he can actually download the data easily, show us a data point. I can't show it here, but you show at the data point, he can easily make a call to these people. Yeah, done. Just like that. Yeah. So that's why I say that it's about convenience. There's also another product that is very interesting that is they use for people who are handicapped in speech and hearing. They have this glove whereby it's a sign, and then they can easily communicate with people that doesn't know sign language.
Oh, interesting.
That's also easy adoption by people. And yes, there's computer vision, there's vocal signs, right? But then this is incorporating into the back-end usage of it. But the front-end usage of it is so easy to adopt. Make sense?
Yeah.
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 So data science have 5 disciplines at the moment. You can't run away from it. Numeric, text, image, video, vocal. 5 of them. And
Can you
throughout
say the
our
last
lives,
one more time? Sorry, I didn't catch that.
vocal,
Oh, okay.
vocal, right? You can't run away from this one.
Yeah.
Vocal, CV, Bixby. Vocal involves vocal plus text for CV and Bixby.
Mhm.
Although if a data scientist come to you, hey, would you actually like to use vocal plus text? I can help you, right? But you actually, why do I use vocal plus text? Is it actually trying to watch me from backend? But then if I present it as a product, CV, Bixby, incorporate into the phone, make a line easy, you're actually using vocal signs and text signs without knowing it. Yeah.
Yeah.
You use YouTube, right? So someone actually say, Jarrod, data science is too complex. I will not touch it. And then the next question I ask the person is, do you use YouTube? I say, yeah, of course I use YouTube. Amazing software. I say, okay. Do you know that YouTube has recommended for you next? And do you know that that's actually literally data science? You use it every day, right? Yeah.
Yeah. No.
So
It's fascinating.
yeah. So that's why adoption must be on face front.
Mm-hmm.
The back end is on what the person don't need to know. So this is actually the layman explanation, the layman upfront, and this is the back end, which the layman will not see. If anyone is interested to see, I can share with the manager, the client manager,
Mm-hmm.
but I think the client manager will fall asleep somewhere down the road. He will say, show me the money, right? Show me the money. And then it did happen, all right? So they actually did a shop that is to run my machine learning model called DSS Customer Observer.
Mm-hmm.
And then this is actually not just making my client happy, it's making the customer of the client happy. He says, my husband and girls arrive at the styling session, and then this styling boutique actually is different because they actually go with your own wardrobe. You can mix and match with the clothes. And then she likes it because it's a different look, and they highly recommend it, and they'll be back.
Mm-hmm.
Why? Because my machine learning model know that it is this person, and then this is the product that she has, and then why is actually the next product we sell to her.
Yeah. It's clear. It's very clear. It's a very
and
clear.
the designer know how to use it as well.
Yeah.
The designer know, oh, I should sell her a bracelet. Right?
Yeah, no, it's wow.
So
No,
this is that, and then the coding one. Maybe I just show a bit of coding for fun, all right?
yeah,
Okay.
sure. I just want to say, Jarrod, we are running a little low on time. So yeah, I was
Running
actually going
low,
to ask
okay.
if you would be able to show us the coding models that you wanted to demonstrate, just so we can.
Okay, I'll just show something that is actually behind. Allow me to maybe also to show a bit about my company.
Yeah,
right?
absolutely.
A bit of my company. So my company is DSS Direct Sourcing Solution,
Mhm.
and that's actually my people. That's my CEO Brian, and then we have various offices, right? And then we have around like 500 over staff. And we even have an office that is looking like that, and a company nurse. Yes, we have a clinic in the office. That's how huge we are. And then that's actually me, 16 years of experience. And then that's actually me doing the some of the projects over the past few years. I'm never on GitHub or Kaggle. It's because specifically I touch sensitive data from MinDev, military data, and government data. So I don't dare to be on GitHub. I don't want to have people appearing on my door and say, Jarrod, sorry, you're arrested today.
Yeah, it's an unwelcoming surprise.
I'm worried on that one. So that's that. That's about a bit about me and my company. And then I'm going to actually show something very interesting. I'm just going to show the end result, right? So the end result is this. This is SPSS. Everyone say that SPSS is lousy software. So this is actually trying to say that this ID, the first default is Gen, right? And this actually says that the first defaulted month is Jan. This is for credit card.
Mhm.
Okay. So when do you first default on your credit card? The second person default on, let's see, December. And this is marked as December. This code is this data is the one that actually make me found my first mentor. Now, this is actually a very interesting problem. And also it highlights on one point that is, so how are you going to approach this problem before you even start to do your first line of code? You see, there's no ending result here. But the end result is I want to find the first time the person default on a loan. So this is January, obviously. I don't want March and April. I just want January. And then this is actually December, right? So I want to find the first ones across the column itself. And during that time, there's a lot of people who just say, oh, write various if statements, and you should actually get the answer, right? But can you imagine the permutation of if statement you're going to get? Yeah. so then my mentor and me actually comes up with this solution. First, we convert everything to text, right? This is doable in Python, I believe in R as well, right? So this is, you can see, all is converted to text already. Yeah. And I'm not actually going if statements, by the way. So why do I actually convert numbers into text? Sounds funny, right? So next, I actually concat everything into one column, all right? And that's done. So that's actually the whole 12 months into one column. Now, this is actually where the magic happens. So after this is done, the next thing I do is find the first default month, which is to actually find the first one that is actually in this text column index. Oh, in Python is something else, right? So finding the first one, this is 1, this is on position number 12, this is position 0, this is position 2, and this is position number 7, right? So after this is done, the next thing I do is to actually just label it. So label it accordingly. So 1 is Jan, second is Feb, and then I do a table. So this actually shows first defaulter, how much are they, who is clean, and all those things. That's all, right? So there are 3 cleans, 8 default on Jan, 1 default on February, and there are 20 customers altogether. So basically, this is that one. This is the first default column. I don't need the rest of the column, so I basically just delete them away. And then that's where you actually end up with this as the final result. So this literally tells me that when is the first default of each customer. That's all.
You make it seem so simple.
This is not simple. I hadn't actually thought of it over lunchtime. Then I was like, oh, okay, I should use it like that. Then another guy who's actually my mentor now. He used to be the chief or principal software engineer of a very major company, IBM. So basically, so he come up with a looping way. I come up with a straight direct coding that I pass it to the person. Last time there's actually no tech stack or something, Stack Overflow, right? There's no Google, no proper channels of Googling for codes. And then we have this forum where it's linked to all statisticians globally. And that's actually where I pass the code to that person. So-called win that question. Like, and I know the mentor from there. He likes my solution. I like his solution, and say, why not we exchange ideas in times to come? He's actually a very, very good Python or whatever software that you can think of. He knows it, and he's a very good statistician as well. He retired already, but then he's a very good machine learning model person as well. So that's actually my luck there. I met good mentors along the way. And then, of course, I don't actually go to them and ask for solution. I thought of the solution first before I ask them again. Say, do you think this does make sense? Then when they say, yes, it makes sense, then I will look at it again and see whether it's possible to implement or not. So I don't literally just go to people to ask for solution. I go and think about it. I don't Google for solution as well. This is not Googleable. Right?
Yeah, I would,
So when people,
can't
when,
imagine.
when there are data scientists who say, look, to be a data scientist, you just need to learn how to Google. That is actually a bit weird because the only thing that I Google during my work time is songs on YouTube. Then I start to code, and I don't understand why people say, the way that to become a data scientist is to know how to Google when I don't even think this is Googleable, right?
Yeah, good luck typing that into the search engine. Oh my goodness. Oh man.
Yeah.
Well, yeah, well, no, it's interesting, especially the notion of kind of deriving your own solutions and then presenting those to whatever business team you're working with, instead of kind of coming with an open platter of, how do we solve this problem? You're already preemptively trying to engage with the ideas that you come up with, and the models that you're building. And I think that that's just in general something very important, for people to consider, anyone who wants to work in business. I mean, I think having, or work with businesses, I think having that mindset, and being able to derive your own preemptive solutions and evaluate them, and then implement them, and then start working with people to see how effective they are. That seems like something, and correct me if I'm wrong, but it seems like something that's very, very important, especially within the business sphere, and life in general. But yeah, no, either way, thank you so much for joining us today, Jarrod. It's been an absolute pleasure. Once again, Jarrod is the Chief Technology Officer at Direct Sourcing Solutions. That is his company, and they're doing some phenomenal work. Feel free to check their website out. If you want to, would you like to plug your company's website, Jarrod?
My company website.
Yeah.
Here you go. This is, let me just, yes, that's Asia. That's actually my company website. Yeah.
Okay,
This
perfect.
is Direct Sourcing Solution. And then we do have a little blog as well on data science as well. And these are actually some of the things that we write here. Plus, this is actually the services that we do. Other than data science, we do digital marketing and other things as well. Yeah.
Awesome.
That's actually our company. Yeah.
Awesome. Well, I'm glad. Yeah, I'm glad we got a little preview here, and thank you so much for talking with me about it, and giving me a little bit more insight into the world of data science. I'm sure our viewers will deeply appreciate that. And on that note, unfortunately, we're going to have to close up today's interview. Thank you so much for joining us on today's episode of AI for Business at AITJ. And thank you again, Jarrod, for being kind enough to provide us with all your valuable knowledge. It's been an absolute pleasure once again. If you like this episode and would like to learn more, please visit us at AITimejournal.com, where you will be able to find plenty more podcast episodes, as well as articles covering a wide range of issues in AI and exponential technologies. Thank you so much.